of momentum with talking about some 2D collisions. So this is a little different than one-dimensional collisions, just in one aspect. We got to worry about a horizontal and a vertical. So that is going to be what we're going to be doing here. So let's take a quick look here. So let's first sketch a diagram. I want you to pause this, give this a read, and let's sketch this diagram. Okay, so I've got the two balls, and they are coming together, and they're going to form an angle of 30 degrees. And then this first one's going to bounce up, and this one's going to bounce down. Okay, pretty straightforward. So the idea of these diagrams, we're trying to show what happens. So let's try this again. Let's sketch a diagram. I want you to pause this, sketch this diagram. Okay, so just as before, I got one ball moving towards another one. This first one is going to glance off there, and then our other one is going to bounce down here, and it's going to form a 60-degree angle between the two paths. Okay? Now, the next thing we're going to do is we are going to add in some calculations. Now, what we're going to be doing with this is we're talking about the two directions. We got to worry about momentum horizontally and vertically. So we're going to have to use a little bit of trigonometry. So you should have a function knowledge of sine, cosine, and tangent to really make this work. All right, so let's take a look at this here. I want you to pause and take a look. Okay, so we've got this red ball right here, and it strikes a blue ball. Hold on. So let me draw the red ball first. The red ball is going to come forward, and it's going to strike a blue ball over there. So this red ball has a mass of 1.20 with a speed of 17.1, which makes a momentum, if you multiply those two together, of 20.5. Okay. Well, then let's set up the blue. Okay, there's my blue ball. It has a mass of 2.31, but this one has a speed of 0. So it means it has a momentum of 0. Okay. Now, what does this mean? Well, what's going to be our total momentum? Well, that's a good question. Our total momentum is going to be (20.5). Now, why is that? Well, this has a mass of momentum of 20.5. This has a momentum of 0. Easy peasy. I want you to think of this even further, however. This is going to have a horizontal momentum of 20.5 to the right, but a vertical momentum of 0 because there is no movement up or down. So that's pretty good. Let's take a look at after. I'm just going to draw a little divider here. And let's take a look at the red ball for after the collision. So after the collision, if you take a look, it says that it's going to have a final velocity of 13.5 meters per second, 23 degrees above the horizontal. So it's going to look kind of like so. Now I'm going to make this into a nice right triangle because we're going to do some right angle trigonometry. This is at 13.5, and I'm going to be finding the speed vertically and horizontally. Now, how am I going to do that? I'm going to use sine and cosine. The setup for this is going to be pretty straightforward. Okay. And then if I do a similar setup, but for cosine, for the x, I'm going to get, and these are both in meters per second. Okay, that's all well and good. But we should be able to find some momentums as well. So Py. So if I multiply each of those by that mass I had at the beginning, that 1.2, I'm going to get 6.33 and 14.9. Okay, so that's going to be really handy. I'm just going to move to the next slide to get a bit more space. Okay, so now I'm going to set things up for the blue ball. And this is where it gets a little bit trickier because we're given very little other than the mass of that blue ball. We do know that the blue ball kind of travels down a path. We don't know the angle of it, though. So I'm just going to draw what I had before. I don't know the angle, so I'm going to label that with a theta. We don't know the speed, but we do know one thing. We know that the vertical momentums is conserved, and so is the horizontal momentum, and therefore the total momentum. Okay, so if I look at my vertical momentum, that's going to be equal to my vertical momentum of the red, but it's going to be negative. Now, why is that? Well, let's take a look at our original diagram. Remember, we said there was no vertical momentum. Therefore, the two have to be equal and opposite, so it can be equal to 0. So that's easy. I can go negative 6.33 kilograms meters per second, which when I divide it by the mass of 2.31, I can get a vertical speed, oh man, that didn't turn out well, of 14.9 kilograms, just meters per second. Oh, I'm skipping ahead. My apologies. I wrote down the value that I had earlier. Allow me to erase that. Okay, that's all right. That's why Apple Pencils have erasers. Let's go back to the pen. Okay, so Vy will be equal to, I take my 6.33, I divide it by 2.31, which was our mass, and I'm going to get 2.74 meters per second going down. So that would make that a vector. Okay, so that's in the vertical. What about in the horizontal? Well, let's take a look here. My momentum before is going to be equal to my momentum after. My momentum after, at least in the x, is going to be my momentum of the red one plus my momentum in the x direction of the blue one in the horizontal direction. Okay, well, I know this value. I just calculated it up here to be 14.9. So a little rearranging. Oh, and I knew this value because that was 20.5. A little fancy rearranging, and I'm going to get and that makes the momentum of the blue ball in the x direction to be 5.6, which leads to a speed in the x direction of my blue to be, once I divide by the 2.3, it should be 2.4 meters per second, again in the right direction. Okay, so if I go back to my diagram here, I'm going to make it a little bigger, just because I can. I'm trying to find this V right here with this direction. However, I know that I've got 2.4 this way and 2.74 this way. Cool. A little Pythagorean theorem action here, and I should get a speed of oops, 3.6 meters per second. Okay. Now I'm going to need this direction, so I'm just going to use a little tangent ratio. And I will get my final direction to be 49 degrees going down. And there we go. There's my answer. So these questions are a little bit more involved, which of course would mean there's not as many of them. So let's take a look. I want you to pause this and give this a read. Okay, so again, we're going to have to look at this both before and after. Let's do the before first. Okay, same masses as before. Okay, so we can actually figure a couple of things out. We can figure out the total momentum first. So let's do that. We're going to take each of these speeds, multiply by each of these masses. Pretty straightforward. Okay, but we need it broken down. So let's take a look. We'll take a look at the blue one first. So the blue one is kind of coming up like so. And it's making a 40 degrees there, and this has got 34.7. So again, using the same approach that I did last time, using sine to find this vertical one, and cosine to, oh, that was weird, to find this one, what I'm going to get I want you to pause for a second, see if you can do those calculations, and then I'll write those in a little bit. Okay, 10.4. That's about what I got, and 6.0. All right. Now, I want you to see if you could pause and see if you do the same for the red. Okay, so for the red, this looks a little different. My angle here is 30. My momentum here was, oh, I had some things mixed up. Yikes. That's okay. We'll fix that in a little bit. And then when I do this out, this should be 6.0, and then this should be 10.4. My apologies, I copied the wrong ones down, so I'm just going to fix that real fast. As I said, this is why Apple Pens will have erasers, and I just screwed that up, so let's start over again. Click the wrong thing. That's okay. Okay. We'll just start over. So, B4. So here I've got a 1.20 kilograms at 10.0 meters per second, making a total momentum of 12.0. Total momentum here, because of the mass of 2.31 and the speed of 15, my momentum here will be 34.7. Cool. So if I bust this out here, I'm just going to draw the whole thing. This is the red one. This is 12.0. Do a little sign here for 6.0. and a little cosine here for 10.4. And then I set this up. This is 34.7, making this one here 22.3, and this one here 26.5. But Mr. Hickey, these two are not equal, you may say, because they share a line. Again, I'm doing a sketch here, and I'm applying values just so that way you can visualize it. It doesn't actually equal out. Okay, so let's get the upshot here. Let's talk about my total momentum in the horizontal direction. I'm going to take my 10.4 and I am going to add my 26.5 to get 36.9 kilograms meters per second. And I'm going to do the same thing for the y. And when I do that, I'm going to get, now these ones are a little different because I've got two different directions, right? I've got 6.0 and then 22.3 going down. So that means I'm going to have a negative 16.3, but it's going to be down. So let's just make sure we have a note of that. Okay. Cool. So far, so good. Now, let's take a look. Or let's take a look at the after. So after, well, let's do the red first. Okay, so in the after, we do know that the red is shooting up this way, makes a 25-degree angle. I know that my total momentum going after, I have a 13.5, so I have a 13.5 meters per second velocity times my 1.20 kilograms should get me a total momentum of 16.2. Okay, pause the video and see if you can find those momentums. Okay. So that's the setup, and let's make sure that you have that ready to go. I'm just going to double check my answers real fast. Okay. Okay, and then I want you guys to pause the video and see if you can set up the blue. Okay. We don't know that angle. Okay, so I want you guys to see if you can figure out the y direction. Okay, so our PY was 16.3 going down, so I'll put that as a negative. There we go. Now I want you to see if you can find the X, pause the video, see if you can find the X direction. All right. Now I want you to see if you can find the result. Sorry, we need to find. I want you to see if you can find the resultant velocities. I'm going to set things up as I'm going to find the resultant momentum first and then use that to find the velocity. So why don't you pause the video, see if you can do that. Okay. Well, Pythagorean theorem action should get me a overall momentum here of 24.1, which makes a velocity of 10.5. Again, I use tangent, opposite over adjacent, and that will tell me it is 23 degrees down. And because this is all important now, because my work is kind of spread all over the place, I need to make sure that I make it nice and noticeable where my final answer is. And there we go. All right. So here is your assignment for this section. There is a two-dimensional collisions worksheet that I want you guys to work on. If you have any questions, feel free to get a hold of me, either emailing me at jeffrey.hakey@nwsd.ca or messaging me on Teams. All right. Take care, and next lesson we are starting energy. Bye.